So hello everyone. So this is our new episode of Q&A with researchers. Today we have with us a very special researcher from Sardinia, Italy, and he's presently doing his PhD from St. George City St. George University of London, and his work is mostly in field theories, and we'll talk to him about his interest and his passions and what motivated him to get into physics basically. So without any further ado, let's just meet Fabio himself.
Hi.
Oh, hi Fabio.
Hi.
Nice to meet you.
Nice to meet you.
So this is just basically a Q&A thing that I've started while I was at Helsinki. So you probably are the 8th one who I'm interviewing. So I just ask questions, and basically you have to feel free to answer them if you are, okay.
If I know what to say.
Yeah, definitely. Okay. So so tell us about your childhood days. When how was your schooling in Italy? You are from Sardinia, so it's an island, right?
Yeah.
So
I mean, normal. I imagine normal way. I just went to public school.
Okay.
Elementary, middle, high school. Wasn't particularly good, to be fair.
So during your school days, what were your major interest in? Were you interested in physics from the start, or?
No. Actually, I am pretty lazy.
Okay.
And, in high school, in general, you think a lot of things. I wasn't thinking at studying too much, to be fair.
Okay.
But I liked the physics. Maybe even astrophysics. The thing that really makes you wonder, when you are
universe,
young,
galaxies,
universe, stars and shit.
Okay.
Without I liked physics and mathematics in the sense that I could understand some stuff, not everything, because I didn't do exercise.
Oh.
I was getting notes.
Okay.
But in the end I graduated from high school.
Okay.
In time, without losing any year.
So your high school was from Sardinia itself, or?
No, in Sardinia.
Okay.
And then I didn't know what to do.
Okay, so
my parents were, you did well. We weren't expecting you to graduate immediately because you are super lazy. But or you work, or you study. So
you chose study.
Yeah. So I choose to study, and actually, the start wasn't great, even in physics, because I was traveling, so I wasn't in the main city.
Because
so I was driving by car every day from my village.
Okay.
Because clearly Sardinia is small. There's one little city and then just villages. So I wasn't studying a lot. But then after 6 months I moved to Cagliari, the main city, and I started frequenting more the environment of the department of physics. So
what was your university where you enrolled in yourself in the bachelor's?
Physics in Cagliari, department.
Okay.
And that's it basically.
So it was in which city, sorry?
Cagliari. That is the capital of the province of Sardinia.
Okay.
And that's it. Basically, I got some friends, some colleagues, and I discovered that I liked.
You discovered that you like physics.
Yeah, exactly. Also, you do stuff for 1 year, 2 years. You understand that sometimes it goes well with exams, sometimes it goes not so well, but you can get that is your fault, obviously. Yeah. And then that's it.
So what in physics we have so many fields. So what particular topic interested you the most in it?
I was for sure mostly I wanted to understand the framework. So I like the mathematics applied to physics from the start.
So you like the mathematical side of it?
Yeah. So after the first year, when you start to do, in Italy, the programs are pretty tight. You do a lot of stuff.
Lots of coursework.
Yeah.
Okay.
And you know, I didn't like lab at all. I couldn't really get anything good out of it. Okay. So yeah, I didn't want to do lab at all. Like, it was very bad. And then yeah, you know, then you start to see a bit of mathematics, and I tried to do as much courses in mathematics as I could, even though, I mean, Cagliari's university is mostly experimental and or phenomenological, like as
so in mathematics basically differential, like topology.
Not even topology. I had to study by myself a bit of topology, but yeah, you know, I mean, actually it's a little university, so I mean, like, for example, with some colleagues, we were praying our professor of theoretical physics to do a course on group theory.
Okay.
And he didn't, because we were three, like, asking, in all the department to do it. So that's like I did my bachelor thesis on that, because I wanted to see that a bit better, for example.
So what was the thesis topic in bachelor's?
Sorry?
What was the topic of the thesis?
No, it was a simple, I mean, just a study on Lie algebras and representations.
Okay, basically group theory.
Just group theory, because I wanted to know that.
You wanted
stuff.
to learn more about it.
So I just did a thesis on that.
Okay.
Okay.
So after graduate, basically doing your bachelor, so for the masters, did you study? Did you stay there, or did you go to some?
Then actually before I moved to Bologna for the master, because they have a.
Bologna is a big city, right?
No, it's not big, but it's one of the oldest universities in the world. They have a very big department.
University of Bologna.
Yeah.
Okay.
Almost 1,000 years old. And they have multiple curricula, so you know, I could choose a theoretical physics curriculum when I didn't have to do any lab. That was the main reason. And I started following the lecture, but actually I was still writing my thesis. And this was a bad choice, probably, in the sense
master's thesis.
No, my bachelor.
The group theory.
In September I moved to Bologna, but I was still writing my thesis and following the course of the master. So I got overwhelmed.
Yeah.
So basically, in the end, I graduated in November from Cagliari, and I started properly. But clearly I was already behind.
Yeah.
So I started accumulating stuff to do, but I couldn't really probably the best thing was just graduate, losing alpha year, and then start the year afterwards. But I wanted to push, and in the end I got delayed in the master because I couldn't follow properly.
Okay. But eventually you got it.
No, actually yes. You know, it's not always easy.
Yeah.
You do a lot of exams, then you get also bored, because I mean, you know, once you get, this is my experience, once you get the gist at times of how to do stuff, and you talk with professor, you have also good relationship with them, and you can discuss with them, you realize that you can discuss with them, because clearly there's also, I mean, some barriers, some walls at times.
Obviously.
Okay, especially with old professors.
Yeah, definitely.
But you know, once you realize that you can do stuff, if you put the effort, it also becomes, every time you have to put yourself into this game of even. Also in Italy, everything is oral exams, and both oral and
oral is the norm there in Italy.
Yeah.
Okay.
So every time is really can become, depending also on the professor, a real challenge.
Yeah.
You know, because clearly, I mean, whatever, it can be super easy, or can be
too difficult.
Very difficult, depending also on the humor and on the on the day, let's say. So I got a bit delayed, then there was COVID, you know.
Yeah.
And during COVID I couldn't do anything basically. I was
It was a hard time for
pretty-
many of the students here.
Yeah, no, so I just read books most of the times. But then eventually I could finish, and then yeah, actually at the start I wanted to do more cosmological stuff.
Okay.
But in the end, I asked this Russian professor that is in Bologna.
Okay.
He does quantum cosmology and stuff like that. But he didn't have any project. So I switched to integrability in field theory.
Okay.
Because I was interested in like, you know, entanglement entropy and all this stuff. And I knew this other professor was really good. And yeah, eventually, yeah.
So eventually
I started doing
the
studying
project.
integrable field theories.
Yeah.
Even though in the end I spent 1 year studying cellular automata.
Okay, biophysics.
No, it's, in integrable spin chains.
Okay.
So
There's a cellular. Okay. I got distracted.
stuff that out of equilibrium dynamics,
yeah.
still integrable systems,
Yeah.
so Bethe ansatz, these kind of things, but in discrete systems. And
okay.
yeah,
That's how you
that's
got
my
interested.
background.
So,
And-
but in a master's thesis, so you worked on this integrability stuff, right?
Yeah, but spin chain, algebraic Bethe ansatz stuff related to spin chains and
Okay.
cellular automata, basically.
So, Bethians that you said.
Yeah.
So, what's with this Bethians? Like, if you can break it down in simpler terms.
I mean, basically, you know, this one-dimensional system are integrable, so they are heavily constrained dimensionally. You have elastic scattering between these particles, and basically you can describe the wave function exactly as a sort of weakly interacting waves.
Okay.
But they interact I mean, they interact like solitons. And you can write down a wave function exactly for every number of particles.
Okay.
And then there are various flavors. You can do this in quantum mechanics, so it's Bethe ansatz, coordinate Bethe ansatz. Then you can take thermodynamic limits, so consider densities, and you know, or you can apply also to other integrable models. Then you can do second quantization. This is algebraic.
Yeah.
Bethe ansatz.
Mm.
Yeah, so
that was
that's
your-
a lot of stuff.
Yeah. So that was your master's thesis.
Yeah.
So eventually you got graduated from University of Bologna.
Yeah, exactly. Yeah, and
So after that, like, what was your track? Do you you joined directly in London?
basically, yes, almost immediately. I mean, basically,
Immediately.
I graduated in March 22,
Okay.
and then I won the application for the PhD in London in April. Actually, yeah,
Tricky poking.
yeah. Let's. We arrived because of
Yeah.
and yeah. So basically,
Yeah.
yeah.
So
actually, I
you-
switched to field theory again, but still integrable.
Yeah.
So,
You switched. Basically, you were doing stuff in condensed matter.
I mean,
It was condensed matter, the spin chain stuff, or?
yeah, no, I mean, yeah, basically that was more condensed matter, but then I switched to field theory again.
So you became more interdisciplinary, basically.
Yeah, but I mean, I didn't actually put up any paper during my master. So actually, yeah, I have a background in condensed matter, like theoretical, but in the end, I never really worked on a project apart my thesis, but this still like stayed there. So.
And how was the experience in the your university in London?
Great. I mean, my supervisor, she's really nice and kind. She helped me a lot, but also she gave me a lot of freedom. Basically, I studied what I wanted, and we were lucky in the sense that we could find some project and make them work in a sense. So I got a good experience. Yeah.
And so during your PhD, so You studied what things? Like if you can just summarize.
Basically,
You worked on
my main subject was the computation of correlation function
okay.
in integrable field theories deformed by irrelevant operators.
Irrelevant operator.
Yeah, so it's TT bar deformations.
Yeah. TT bar is also quite famous in the like holographic entanglement entropy people.
Yeah,
they work on TT bar.
We start from a CFT, in 1+1, you deform it with some irrelevant, you first flow to a massive theory, so you perturb with some relevant coupling, integrable still, and then you perturb it again with some irrelevant coupling. And what you get is a theory with some pathologies, but still integrable because this kind of deformation preserve symmetries. So all the conserved charge gets deformed, but they are still conserved. So you get a theory that is pathological in some ways, but you can do still a lot of work because it's still integrable. So you can calculate the spectrum and also try to, our work was to compute the 4 factors, that is this matrix element that you use to then compose the correlation functions. And maybe let's go there.
Sure.
And yes, so basically this could be done because basically this deformation, the power is that in integrable field theories that you can use is S matrix bootstrap. So the idea is that you can compute exactly this matrix, and that's the only thing you need to obtain everything, both thermodynamic Bethe ansatz and form factors. Because this is elastic, it has a very nice analytic properties that you can define exactly. So in this kind of deformation, irrelevant deformations basically consist in just adding to this S matrix of the original massive field theory with some CDD factors that are named after Castillejo, Dalitz, and Dyson. Are basically some small terms that deform, that satisfy the S matrix bootstrap trivially. And then you can add to a S matrix of a model, and then you can see how everything gets deformed. And we studied these kind of things. So actually then you can, there are various kind of observables, so you can, let's take the simplest theory ever, that is Ising model. So you get -1, that is the S matrix of Ising, deformed by this CDD factor. And then you can do TBA, but this was already done. But then with my supervisor, our collaborator, we try to apply these 2 form factors. There's this procedure is called form factor bootstrap. There are some axioms, axioms, not axioms. But
axioms from math.
That you have to impose on this correlation function, and you can basically compute them recursively. Like you usually have some constraints that are physical, like where are the poles, the analytical structure, the symmetries, CPT, Lorentz invariance, unitarity, usual stuff. And you have different kind of observables, so you have like local observables in principle, and then also twist field, so that you can use. For example, my supervisor, she's really an expert on calculating entanglement entropy using the replica trick. So we calculated also, we tried to calculate the entanglement entropy using the replica trick.
Were you successful? Were you successful?
We did something, but the fact is, like, we didn't. This deformation give a lot of freedom. So, and also the equation that determines these 4 factors that used to compute correlation function depends heavily on the locality properties of the fields. and this irrelevant deformation modify the observable locality property.
Okay.
So what we understood is that the solution we got were very general, but at the same time we didn't know how to fix them exactly.
Okay.
So we tried to solve the equation with what we had. We know what we knew was right,
Okay.
and we got some solutions, but they weren't unique, basically.
Okay.
So now we are at the point where we kind of understood how to fix them,
Oh, that's nice.
but they are non-local. So
they break locality.
yeah, they seems to break locality. That is expected actually, because these are irrelevant deformations,
Okay.
right? So you expect them to be non-local. Actually, they say the idea that comes from algebraic QFT is that they should satisfy some kind of weak locality property called wedge locality. But we are still working on it, because clearly it is, once you understand this thing, you also understand that basically you need to modify the equations of different factors. So there's still a lot of stuff to do.
But you have also started writing your thesis, right?
Yeah.
Because you want to graduate as fast as you can.
Yeah, no, I mean, I have just 3 years of funding and it's finishing.
Funding issue, like in UK there's a funding problem, right?
Yeah, I mean, but this was, I knew it from the start, and from the start of the contract 3 years ago. So
you prepared yourself.
Yeah, exactly. So now I am moving again in Italy, and I'm plan to write the thesis and then see what's coming. So find postdocs, very hard nowadays.
So for your postdoc, what would be your preferred choice? Would you like to continue in London or?
I don't mind actually. I like to travel. But the thing is that it seems good is also to continue to work on this stuff I'm working, but also trying to open
to new possibilities,
new stuff, because that's, I mean, also talking to people, it seems like the more you know, also the first postdoc is a bit like a second PhD.
Obviously.
You still have a long way to go.
Long way to go.
So the idea is to learn as much as possible. And then let's see what happens.
So what would be your advice for the young researchers, for example, bachelor's and master's students who are in the physics research field?
This is fun. The first lecture ever of my bachelor, basically, it was analysis 1, right? That's the thing that you always do. And in Cagliari was we had the class together with mathematics students first year, and so we had a mathematics professor. And basically the first thing that this professor told us just to keep down the
what he
everyone
told?
He just said, okay guys, remember that this is nothing, a bachelor is nothing, a master is nothing. If you want to be successful, it will be a long way to go. So keep it low, I mean, and just work hard by yourself also. I mean, if you cannot do stuff by yourself, or like, this doesn't mean that you always have to work alone. It's not that. But you have to put effort, and like, a bachelor is nothing, a master is nothing, probably even a PhD
is
nothing. I think this is too harsh. Okay.
I think in a sense we get
but you know, every time you have to put stuff into perspective, in a sense. And have present that everyone is different, so everyone can help in some way. Everyone is good if it puts the work and can do something. Clearly there's this problem that you see Einstein every time, you see Ramanujan every time, you see these geniuses that did a lot of stuff, but that's not what it's about, okay?
Einstein was also considered a lazy person, like a lazy student, like you. So.
but
eventually, who knows like what is going to happen.
Yeah, exactly. So I mean, you shouldn't aim to that. That's you shouldn't. You should aim just to work on the stuff you like. Clearly, it's important to survive. I'm not saying.
Survival is important.
I mean, but you have to find some equilibrium.
And there's some tendency in like in modern times, like publishing paper. How many papers? People like
that's
quibbling
very
about
annoying.
papers.
But you know, there we are flowing towards another huge black page, let's call it, or stream of because you know everything is dictated by money, and then you know,
but
the publishing houses just want. I mean, it's another big issue. You know, it's that I mean the quality of research clearly goes down.
You think that quality should be given more importance than the quantity?
Yeah, absolutely. But at the same time, you know that you know people. I mean, the population is increasing. There's more people that does the same stuff.
I
mean, at the same time, it's difficult. I understand this. I mean, I'm not one of those that say, okay, no, 50 years ago it was better. Also because everyone is saying the same from when mankind exists. So I think this kind of, let's say, way of putting things is a bit too harsh. But there's for sure needs to be like put things in perspective. Like that's so okay. If you're a bachelor, you're no one. If you're a master, you're no one. But even if you are like Albert Einstein, you just become dust. So it's whatever. You know? So
that's your advice.
That's my message.
Okay. Thank you so much. Thank you so much for talking to us and giving your input to our research community. What you told us about what you talked about, what you research, and also gave some important advice to young researchers.
I hope I can be. I don't know if this is useful stuff, but
this is obviously useful stuff. Like
let's see.
Let's see. So all the best for the future ahead, and wish you all the best for your thesis and successful postdoc and career. So thank you. So this was Fabio, and links for his papers would be somewhere. Obviously I have to tell them links of his paper, like I will just put the Inspire-hep profile
talking about
so it would be somewhere down below, and if you have any questions for Fabio, just put them down in the comments, and I would just pass them to Fabio, and he would definitely be ready for answers. Like okay, so have a nice day everyone, and thank you for watching.